The previous two speeches, I think maybe someone wants to know how to test it. So this time we also invite the global leading testing instrument vendors to share their opinion on this topic. First, let us invite Mr. Enwiku from Keysight to share their perspective. Welcome.
Hello. Hello, good afternoon. It's always interesting to get a presentation slot after not too long after lunch, and then but it's a privilege to present after two of our key partners, Oppo and ZTE, on this topic. So my name is Ku. I guess you can tell from my accent, I'm from Singapore, so hopefully my Singaporean accent is still understandable to you. So the topic I have today, again, is going to be maybe a easy presentation because I think the heavy lifting has been done by the previous speakers on this space to earth, what Keysight causes. We're going to be focusing our discussion on the design challenges. Obviously, as ZT has mentioned, right, sometimes when you're developing a base station or Oppo, you're developing a device, there'll be cases whereby the other peer is not available. Device, the base station may not be available, and then now the question is that when you want to test, do you always need a satellite to be launched in the sky before you start testing? Okay, so these are the proposed agenda. I'll just try to go into the slides in the interest of time, but mainly I'm going to be talking about the satellite options. There are various discussions about direct-to-cell, modified, proprietary, release 17 to 19, touch on some of that, but not to go into the details. I'm mainly focusing my speech on the design challenges and testing considerations. With Keysight, we're basically launching a Sky to Lab solution portfolio in Mobile World Congress, I guess next week. We've been working on this portfolio for the past 3 years, and now this is basically a branding that we're giving to our portfolio, and then highlighting a few industry collaborations. And I guess for some of you who may have already seen the slides, will be China Mobile, ZTE, and as well as Oppo are some of our close collaborators among others. Okay, so mainly on so I think there was actually an interesting question just now from Mr. Tang, or I'm not sure, Dr. Tang, about what the industry would be potentially adopting from proprietary unmodified direct-to-cell, and then new radio, narrowband IoT, new radio, or NTN, narrowband IoT, and as well as NTN new radio across release 18 to 19. With Keysight, we've been collaborating with our partners to basically experiment different techniques, including proprietary and direct-to-cell and others, right? But especially including the hubs as well. So I think hubs is obviously picking up in popularity with WRC 23 last year, basically assigning dedicated spectrum for hubs. And then in certain regions, for example, in I guess Japan, for example, hubs is actually seen to be pretty important in terms of providing coverage and capacity for disaster recovery and others, right? And then there are obviously projects beyond 5G that goes into 6G that we discussed about satellite backhauling. So in other words, with hubs, obviously you get a base station on board, but it's pretty expensive. And now the question is that if you want to be able to make sure that you can get widened coverage, especially into areas where by hubs, you need to be able to get connected to the ground station at some point in time. And if you have a large scale disaster, hopefully that will not happen, then you will not be having the base station on the hubs to be connected to the ground station. Then you need to be able to go through the satellite backhaul. But in a nutshell, we are basically seeing operators experimenting in what we call the multi-layer satellite options. And then obviously some are in commercial deployments, but I would say largely this is still a space whereby there are quite a few experiments in progress to look at what are potentially the best strategy for the operators. And we refer to operators, it will not just be the case of traditional cellular operators, but satellite operators and providers as well. What I would like to highlight in this slide as well is in terms of, I guess, common knowledge. With GEO, right, the satellite doesn't really move, so in other words, the Doppler shift would be pretty much negligible. But then in terms of the distance, latency is pretty high because obviously it's quite far away from the Earth's surface. Then we look at LEO. You would have potentially the most promising aspect in terms of delivering high capacity throughput, right, to the ground stations, but obviously because it's constantly moving, if you're looking at, for example, 600 kilometers away from the Earth's surface, the ground terminal barely gets connected to the satellite in less than 6 minutes, right? So then the Doppler shift will be high, even though the latency is relatively low. And hubs, obviously, I think the key thing is really around making sure that you can get adequate coverage but then the capacity per unit area is potentially the highest. And then, but you got mobility among all, right? Because the satellite move and then you move, right? What do you do to test all those scenarios? In terms of the options that we're looking at, I have not included proprietary options. What we meant by proprietary options are basically satellite is not new, it's been around for a long time. We're seeing a big shift right now in terms of satellite providers going to 3GPP, trying to potentially latch on to the 3GPP ecosystem, right? The main reason, I guess, is, as Oppo has mentioned, is the economies of scale. Roaming is a big play. Obviously, if you look at how GSM basically took over the rest of the technologies to become the de facto technology of choice for mobility, it's basically roaming among other aspects. So when we look at a modified 3GPP, the device by itself is not modified. You don't actually require any modification to your device. The modifications are based around the base station and the ground station predominantly. So then, as previous speakers has explained, there are pros and cons of this approach. The pros obviously is that you can get immediate coverage with your device, but you will not expect very high throughput per se, right? And there are a few challenges to be explored, and I would say it's not confidential information, but Keysight, we do actually help operators to look at how we can emulate the constellation related impairments, especially in terms of Doppler shift and as well as latency in our base station emulators to test devices to make sure that when operators like T-Mobile US, when they start to look at deploying unmodified with Starlink, then the user experiences will not be impacted. And now the question is that what will be the impacts to the capacity and of the base station. Release 17 and 18, I think is pretty much said already. Obviously, dedicated signaling enhancements has been put in place by 3GPP to enable two variants of NTN, the narrowband IoT and as well as the new radio being the high capacity variant, but then obviously it's going to be a longer time in terms of deployment. There's going to be pre-compensations which are needed or post-compensation on uplink and downlink. As I mentioned, the two main things are in terms of Doppler shift and as well as latency, but obviously the other things like atmospheric impairments. Now, when we look at Release 19 really excites us because it involves basically hosting the base station in the satellite. There were previous discussions about, why do we actually need to host the entire base station in a satellite? If you speak to some of the satellite providers, there are lots of concerns around the energy consumption of the entire unit being in a satellite, because in a satellite, with the only power source being available being solar, you definitely need to get to net zero. So quite a few satellite providers, if you go to 3GPP, they'll basically say ideally they would like to see how RU and DU are basically being hosted in the satellite and the CU remains on the ground. So energy efficiency is a big factor, and again, with regenerative, there are multiple additional use cases can be enabled from both delay tolerant use cases and as well as low latency reliable use cases. So those are the things that we're looking at. So I'll get to the design and test challenges. So there are three main areas that Keysight, our customers, are looking at. One is in terms of the propagation conditions. Obviously, you've got a mix of constellations that I mentioned, and operators are basically exploring a diversity and variety of satellite options. So the question is that how do you make sure that you can simulate the conditions, emulate the realistic conditions for them to be able to develop their devices, their base station, and very importantly as well in terms of the payloads to be transferred across the satellite link depending on the applications and the service level agreements. Then obviously there are things like fading, shadowing, atmospheric impacts. The modeling of the multiple satellites will be important, and we look at, for example, the terrestrial networks and non-terrestrial networks interworking as well. That's one key aspect to consider for service continuity. I would say, we have actually looked at satellite testing experiments in a very diverse way, ranging from unmodified all the way to beyond Release 19 researchers. Some of you may have seen the announcement that one of our partners, again, this is public information, that Lockheed Martin is a famous aerospace and defense company in the US. They have sent out a press release late last year that Keysight has been working with them for beyond Release 19 researchers. Basically, they are planning to launch a DU and RU in the satellite sometime this year, right? Basically, it's supporting LEO and NTN and MR. So again, it's a diversity of technologies that we're looking at, not just in terms of unmodified, but ranges from Release 17, 18, 19 and beyond. From the performance perspective, obviously the key ones are the throughput, latency, sensitivity, all in the view of mobility. And then conformance testing. So with Keysight, we do have a diversified portfolio that goes from pre-standards researchers all the way to device certification to make sure that operators can deploy them, ensuring that the NTN devices are basically in good conditions when providing the quality of service that's required or demanded by the subscribers. Energy efficiency is a big one. If you're interested, we can have a further discussion. Say we are basically speaking to some of the early 6U researchers for NTN in terms of when you start to look at striking a balance between energy consumption with the base station and satellites, and as well as what sort of scheduling algorithms, right, will need to be implemented within the MAC that's going to be hosting the satellite instead of the ground station. So now the question becomes, how do we test all this, in the lab? This is where, Keysight, we are bringing to the market the NTN Sky2 Lab solution. As I mentioned, we've been working on this portfolio for the past 4 years, I would say. This is just a branding that we're bringing to the market. This is not a brand new portfolio, it's industry proven. Within Keysight, we have a UE emulator. So the UE emulator is basically emulating lots of UEs, different conditions, and it's a mix of devices we can emulate within the same software, right? Basically NTN new radio devices, NTN narrowband LT devices, regular devices with different mobility patterns and channel conditions. And then this will basically allow us to be able to test the base station, like for example what ZT has mentioned in their presentation. And then on the right hand side, we have a base station emulator. The base station emulator basically emulates 4G, 5G base stations, again supporting NTN is one of those, but it's been around for a long time. It supports the device testing for 3G, 4G, 5G, even 2G handsets. Now with both bits in place, we basically got a back-to-back test setup. And in between, we have a channel emulator. The channel emulator is able to emulate all kinds of conditions, different constellations, including the required Doppler shift and as well as the latency impairments, right, basically to the service and feeder link. And then at the bottom, you basically see an analyzer. This is what we call the wave charge. So when you do testing, basically you're able to capture all the signals in the feeder and as well as the service link at the time domain IQ, so you can do full bandwidth analysis. So with this approach, we basically would be able to emulate the devices, emulate the base station, emulate the satellite for all kinds of conditions, and you get a back-to-back setup. There's no need for any commercial prototype devices, base stations, or even getting your satellite to sky, right, before you can start to test. That's what we have been bringing to the market. And in fact, a lot of researchers have actually been using this portfolio for them to be able to do pre-standards experiments, given that for pre-standards, you don't actually have any device on the test per se. Okay, so these are the 3 key test setup. As I mentioned, on the left-hand side, you basically have the experimental end-to-end test bed, whereby everything is from Keysight. You have the UE emulator connected to the PropSim, which is basically a channel emulator, to the base station emulator, and then the air monitor will basically monitor line rates basically over the service and feeder link. When it comes to when you start to have devices available, prototypes even, the blue color boxes are the device under test, whereby it's the base station emulator and as well as the channel emulator can be connected to the device and test and optimize the device that goes through the life cycle, design to certification. The right hand side is basically the base station testing, where the device under test is the base station. So one test setup basically with solutions which are versatile enough, right, to be able to support end-to-end experiments, UE, and as well as base station testing. And includes obviously mobility with multiple subscribers emulation and the profiles that you want. So this is a test setup, as I mentioned, right? The device under test is the UE, and then I guess you'll get the slides after this presentation. I'll leave it to you to read the details, but same set of test tools, just that the device under test are different. And the next slide here basically is a G-Node B. The previous slide is the UE, is the device under test. This slide here basically shows a typical test setup for the base station under test. You have the UE emulator, and the UE emulator and the base station emulator basically would perform the pre-compensation, as I mentioned, for the Doppler shift and the delay, and implement all the necessity as required in the 3GPP standards in terms of increased hard queue processors and others, and the impairments obviously. Okay, so in terms of the energy efficiency and savings, Keysight has been developing this portfolio for the past 2 years. We started working with Vodafone in the UK as well as Rakuten Mobile in Japan to look at how we can try to measure the energy consumption efficiency and savings of the radio and as well as the base station. So as I mentioned, right, this portfolio right now is actually being applied in terms of understanding how to optimize the base station, especially whether this is the entire GNOD B or the RUDU residing with disaggregation within the satellites. The whole intent is to make sure that when you start to look at implementing energy savings algorithms in the base station, it does not impact any of the services experience, including coverages. Okay, getting to the last few slides here, and I wanted to take this opportunity to thank our partners, which has really made the impossible possible. In these slides, it's actually been shown that we've actually been working with China Mobile for China first lab verification of NR NTN base station and service. Over here we have is the device under test is the ZTE base station. This is by no means trivial, right? It's really one of the very early successful implementation of ZTE NTN new radio standards base station, where basically use our emulator and the channel emulator that supports LEO, GEO, as well as the wave charge that analyzes the signals to try to optimize the service link and the feeder link quality when issues occur. And then this is basically another important collaboration that we have with ZTE and Oppo. The device under test in this case would be the UEs. And same thing here, we basically applied to our base station emulator and as well as the prop sim together with the analyzer. So again, it's 4 test tools, different combinations of UE, base station, and end-to-end testing. This is basically a press release that we actually sent out earlier this year. Skylo is one of the early adopters, as you know, basically for NTN's narrowband IoT. As I mentioned, our portfolio basically supports the entire life cycle of NTN development, from pre-standards experiments to device certification. So it's a press release that we've actually sent together with Skylo that we're helping them with device certification using the same set of test tools, right? So no new test tools, but basically covering the entire life cycle of technology development. And then this was some of the press releases that we've actually sent out from Keysight perspective for Mobile World Congress last year. This year, we would like to invite you to come to the Keysight booth. We'll be demonstrating additional capabilities for NTN new radio and as well as narrowband IoT development in our booth, right? So it's a diversity of partners that we're working with. With that, this is my final slide. I know I went through quite a fair bit. Hopefully I can summarize everything within this slide here. Again, we are very excited with the opportunities that has been created by NTN, and operators are definitely seeking a multi-layer satellite networks experiments journey. And then on the second point is in terms of there are new challenges that we need to be able to look at, which is very different as compared to testing for terrestrial networks. Things like radio impairments, obviously associated with different constellations, Doppler shift, latency, the interworking between NTN and TN. Energy efficiency and savings is one that we came across for regenerative architecture that's basically driving the needs for new testing methodologies without needing to launch a satellite to space. And then we do actually have an industry-proven portfolio that we've been collaborating with our partners that we developed over the years. And we are obviously very, very happy to be part of this journey, enabling our partners. So with that, thank you very much for your attention. Happy to answer any questions. Thank you.
Thank you.